So in the last section, we've got to look and talk about what a regular polygon is. So on Monday, we started talking about what a polygon is, all of our different classifications. We also talked about that for each type of polygon, they have a specific angle sum. So just like a triangle always adds to 180 degrees, a quadrilateral always adds to 360. A pentagon always adds to 540, and so on and so forth. So we know that we have a specific angle sum for each type of polygon. So we're adding to that one more piece, which is our regular polygons. So let's talk about what they are. First of all, equilateral polygon. What's equilateral mean? Good. All sides are congruent. All the sides are congruent. What do you think equiangular then means? Good. All the angles are congruent. And notice that that includes both interior and exterior angles. So if it's equiangular, interior and exterior angles are congruent. So if I have a polygon that is both equiangular and equilateral, it is called regular. So when you see the term regular pentagon or regular octagon or regular quadrilateral, you know that that means that it has all the same sides, all the same angles. So if you look at your picture here, first of all, tell me what kind of polygon is that? It's a hexagon. Now, if I wanted it to be regular, then I would have to know that all my sides are the same. And I would also have to know that all of my angles are the same. So if I know all sides and all angles are the same, then I know that it is a regular polygon. So if I know that I have a regular polygon, then we could pretty easily figure out what the measures of my angles should be. If I know all the angles are the same, then I can pretty easily figure out what each one of those angle measures are, okay? If I know that the sum of all the angles has to add to 180, if I'm talking about a triangle, and I know that all three angles are the same, how could I figure out what the measure of each one is? Yeah, if I know I've got a triangle, they're 180 degrees total. I've got three angles, and it's being split evenly, so 180 divided by 3, and what does that give me? 60. And we talked about earlier in the unit that if we had an equilateral triangle, all of its angles had to be 60 if they were all the same. So we also have a formula that we can use to help us do that for any other type of polygon. So we take the interior angle sum, n minus 2 times 180, and divide that by the number of sides, or n. We can also do the same for an exterior angle. So if I want to find one interior angle measure, interior angle sum, n minus 2 times 180, divide by that by the number of sides. What was the exterior angle sum always? 360, and we talked about that on Monday, that regardless of whether I have a 20-sided figure or a 5-sided figure, all the exterior angles must add to 360. So if I want to figure out what one of those exterior angles is, take 360, divide it by the number of sides. Now, important thing, and we looked at this on our homework assignment just a minute ago. An interior and an exterior angle, what do we know that they always have to add to? If I'm looking at an interior and an exterior angle, they have to add to 180 because they're making that straight line. So we know that an interior and an exterior angle of a polygon are always supplementary. They always add to 180. So in our first example, we're going to use those formulas that we just looked at, and it wants us to find the measure of each interior and each exterior angle of a regular 15-sided polygon. So key thing here is that word regular. Now, if it just said a 15-sided polygon, I could figure out what the sum should be, but unless I know that each angle is congruent, then I cannot figure out what each angle would have to be. Okay? So the only way I know that all my angles are the same is if it tells me that it's regular. All right, so ideas. Well, let's start with my interior. What is my formula that we just looked at for interior? N minus 2, and then do what with it? Times it by 180. So 15 minus 2 times 180. And that's going to tell me what all of my angles add to. But then, that's being split up how many different ways? How many angles will I have if it's 15-sided? I'll have 15. So then I'm going to have to divide that by 15 to figure out what each angle should be. So 15 minus 2 does give me 13. 13 times 180, what's it give me? Good, 2,340. So all 15 angles have to add to 2,340. But it's being split evenly 15 ways since I know that they are congruent to each other. So what would each interior angle measure? 156 degrees. So if I have a 15-sided figure that is regular, each interior angle would have to measure 156 degrees. All right, it also asked me to find an exterior angle. So what's the exterior angle sum for any polygon? 360, good. So 360. And it's being split how many ways? 15. And what does that give me? 24 degrees. So each exterior angle of this 15-sided polygon would have to measure 24 degrees. Can I check myself? Yeah. What do I know these two numbers have to add to? 180, and do they? Yeah. Yes. So in the second one, it's asking us to work backwards a little bit, because this one is telling me that I have some polygon and we don't know how many sides it has. That's what it's wanting me to figure out, is how many sides would I have to have. But what we do know about it is that it has an interior angle sum of 1,440. So that's going to be important to us. Any ideas on maybe how I could figure this out? Well, how do I figure out interior angle sum for a figure? Number of sides minus 2, and then do what with it? Times it by 180. So I know they took the number of sides, and we don't know how many sides, but they took 2 away from it, times it by 180, and it gave them 1440. So how can I go about solving this equation now to help me figure out n? Yeah, I'm going to first have to undo this multiplication, and we're going to have to divide both sides by 180 degrees. So that's going to leave me with n minus 2, and now that nothing else is over there, I can lose my parentheses. And then what is 1440 divided by 180? 8, okay? So how many sides did my figure have to have? 10, good. We have to add 2 to both sides to finish it out. So n is 10 sides, or what's it called? Decagon. So this one we're just essentially working backwards from what you were doing. Before I was saying, here is the number of sides, find the sum. So the last one's kind of also asking us to work backwards here. It's asking us to find the number of sides if a regular polygon has an interior angle of 162 degrees. So it's giving me an interior angle measure, and it's telling me I've got some regular polygon, and I'm looking for the number of sides. So I'm looking for n, okay? So we had a formula that I told you at the beginning of class to find each angle. We would take the angle sum, n minus 2 times 180, divide that by n, and that would give me my interior angle, okay? The But that's kind of hard. It's going to be kind of hard to solve for. Not impossible, but a little bit harder to solve for if I've got all those ends in there and I'm dividing and all of that jazz. Okay? So how could I really easily find the exterior angle of this polygon? How could I figure out the exterior angle of this polygon? So even though it gives you an interior angle, it's going to be much easier for us to find the exterior angle. So an exterior angle, I'm going to take 180 minus 162. And what does that leave me for an exterior angle? So we've got 18 degrees. So that's an exterior angle. Well, we know that we could find that exterior angle by taking 360, divide by the number of sides, and that would have to give me my 18 there. So how can I now solve that to figure out what n is? Well, what am I going to have to multiply by first? Yeah, I'm dividing by n, so we got to multiply both sides by n, which is just going to cancel here and then tack it onto that side. So now I've got 360 equals 18n, and how do I figure out my n now? Divide by 18. So how many sides did my figure have? Say it again. 20. So even though it gave us an interior angle, easier for us to figure out what the exterior angle in terms of solving. So take 180 minus the interior, that gave me my 18. So every exterior angle is 18 degrees. We know that that came from dividing 360 by the number of sides. So we can set that up, solve, we figure out that this had to be a 20-sided polygon.